what I want you to do next is that you've got on slide 4. Okay, so what I want you to do now is we're going to look at one of our new subscriptions. If you want to click on that link and open up that link. Okay, so this is just like a little simulation basically of the thing. So what you do is you can, so we're starting off on the emissions tab, as you can see there. Okay, and so you've got your Leslie cube there, which has got 4 surfaces, grey, white, shiny copper and matte black. Okay, and you've got your infrared thermometer there. Okay, so what you've got to do is, for the grey one, if you click on plot bar, that'll give you the bar to 63 degrees. Okay, then change the surface by clicking on the different colours and then plot the bar each time. Okay, good. So looking at those results then, Katie, which one is the best emitter of infrared radiation? Okay, good. Which is the worst? The shiny copper one. Okay. So what colour would be the most effective if we wanted to have a radiator in a house and it's going to give out the biggest amount of heat? What colour should we all be painting our radiators, do you reckon, Katie? It does, doesn't it? But it's true. For them to actually be the most effective at heating the room, we would go through our house and we would paint all of our radiators matte black. I can't imagine it would look particularly nice, which is why we don't do it, and it doesn't really fit in with many decorating schemes having a black. But from a physics point of view, a matte black radiator will heat your room a lot more efficiently or effectively than a white one will. Okay, because it is better at emitting infrared radiation. Yeah, but you're right, it does sound strange for a radiator. Do you want to now click on the absorption tab across the top then? So this time we're using it the other way, or it's the same kind of idea. Okay, but this time what you've got is you've got in the middle, you've got a heater. Okay, either side, on the left-hand side, you've got a matte black surface, and on the other side you've got a shiny surface. Okay, and I think, is it things stuck onto them? I can't see, I'm going to just have to, yeah. And the weights that you can see, they're stuck on with candle wax. Okay, so the weights are stuck on with candle wax, and you turn the heater on, and you time to see how long it takes for those 2 metal weights to fall off. And that gives you an idea of how much of the heat has been absorbed, because the quicker the heat's being absorbed, the quicker the weight is going to fall off. Okay, so do you want to click on the play when you've read it and when you know what's happening? Okay, click on the play button and see what happens. Okay, so there you go. Will the other one actually fall off eventually, or it stops after 5 minutes, doesn't it? So which one is the best at absorbing? Which is the best at absorbing infrared energy? Good. So the matte black one is best at emitting infrared, and it's also best at absorbing infrared. So which car would you rather be on a very hot sunny day, Katie? Would you rather be in a matte black car or a white car? Or a shiny silver car even? Okay, good. Why? Yeah, exactly. Yeah, so it doesn't absorb the thermal radiation as quickly, so it doesn't heat up as much. Okay, so sitting in a black car in the middle of summer can be really unpleasant because it absorbs so much thermal energy that it just gets very, very hot. Okay, right, if you want to go back to your web now, okay, and if you want to move on to slide number 5. Now for this one, you've got to plot the graph. Okay, so it's a very simple graph. It's only got three things that have got to go on it. Okay, remember it's a categoric data, so it's going to be a bar chart. Okay, so you're going to probably I would suggest using the rectangular shape thing for plotting your bars. I see you're linking the colour of the bars to the colour of the surface. That's a good idea. Except for shiny black, we can't really do shiny black, but do. So you can see there, can't you, that it's not only the colour that makes the difference, because the matte black and the shiny black, the matte black is actually better at emitting than the shiny black is as well. So it's to do with both colour and whether it's shiny or not. Okay, that's good. If you want to go on to slide number 6 then, Katie. So thinking back, so this is, we're talking about that previous question. Okay, what are the control variables? So think about how you would have done that experiment. What are your control variables? Yes. Yeah, so this is using the Leslie cube experiment, yeah. So if you were measuring it, what would you have to control? That's it. And what was the other control variable? Not so much the time, because really we're trying to do them all at the same time, because the reading with that thermometer is kind of almost, what are we trying to, why did I say we had to try and take the readings? Once you've got the Leslie cube, once you've given it time for it to have warmed up all the sides, I said you then have to take your readings really quickly. Why were we trying to take the readings quickly? To make sure that what hasn't changed between the readings. So the idea is it's the temperature. We're trying to keep this good. So there isn't any heat loss, so the temperature is the control variable. Well done. Yeah. So the actual variable that you're controlling is temperature. So do you want to point that out in your answer? So the control, one of the control variables is temperature. Good. Brilliant. Well done. So what was the independent variable in the experiment? Oops, sorry. Oops. Sorry, you carry on. So the independent variable, that's the thing you're changing. Good, it's the surface, isn't it? Yep, good. Okay, and the dependent variable, that's what you measure. So what is the dependent variable? What is it we're actually measuring? Good. It is. It's the amount of infrared radiation. Well done. Yeah, so you've got to try and remember those two words. So the independent. Yeah, I know that's really common. I'll try and have a few of these as we're revising so that you can get used to them a bit more. Yeah, so the independent is the one that you change. Okay, the dependent is the one that you're measuring. Okay, so what are the sources of error in this experiment? In other words, why might we not get exactly the same results each time we do this experiment? Good. Yeah, that is the big thing. It's down to whether the temperature has reduced. So if the temperature is reduced, okay, then that is going to skew your results. Okay, that's fine.